This lesson helps you understand direct variation. A relationship represented by the function y equals kx is a direct variation, where k is the constant of variation, and k can be any real number except 0. Examples of direct variation would be y equals 5x and y equals negative 2/3 x. When x and y are related as a direct variation, we say y varies directly with x. In order to determine whether or not an equation is a direct variation, solve for the y variable. For this example, begin by subtracting 12x from both sides. Then divide both sides by negative 3. Since the equation has the form y equals kx, the equation is a direct variation. For this example, begin by subtracting 4x from both sides. Then divide both sides by 2. Since the equation does not have the form y equals kx, it's not a direct variation. From a previous lesson, you learned that an equation of the form y equals mx plus b is a linear function. So you can see a direct variation is a linear function where the y-intercept is 0. And the graph of a direct variation is a line through the origin. If the constant of variation is positive, the line goes uphill left to right. If the constant of variation is negative, the line goes downhill left to right. Here's an example of the kind of question you should be able to answer. Suppose y varies directly with x. If x equals 6, when y equals 30, find the equation that relates x and y. Then, what is the value of y when x equals 8? Start with y equals kx. Substitute x equals 6 and y equals 30. If you divide both sides of the equation by 6, you can see k equals 5. So the equation that relates x and y is y equals 5x. Then, if you start with the equation and substitute x equals 8, you can see y equals 40 when x equals 8. There are many applications of direct variation. For example, suppose the amount of your pay varies directly with the hours you work. If you earn $120 for 8 hours of work, you can find the equation of variation. Start with y equals kx. Substitute x equals 8 and y equals 120. If you divide both sides by 8, you can see k equals 15. And the equation of variation is y equals 15x. Then you can use the equation to answer other questions. For example, if you work 12 hours, you earn $180. Also, if you want to earn $300, divide 300 by 15, and you can see you have to work 20 hours to earn $300. You can graph the direct variation. Hours you work are shown on the x-axis. The amount of your pay is shown on the y-axis. In a real-world example like this, notice you have to scale the graph. Each grid mark on the x-axis is 2 hours. Each grid mark on the y-axis is $30. So here's the point on the graph for 8 hours and $120. Here's the point for 12 hours and $180. And here's the point for 20 hours and $300. If you start with the function of direct variation and divide both sides by x, you get y over x equals k. So you can see when a set of xy pairs varies directly, the ratio of x over y is constant. Also, the ratio is the constant of variation. So for example, for the data pairs shown in this table, you can calculate the ratio of y over x. 3 over 4 is 0.75, 6 over 8 is 0.75, and 9 over 12 is also 0.75. Since the ratio of y over x is constant, you know the data pairs vary directly, with a constant of variation equal to 0.75. So the equation for the direct variation is y equals 0.75x. And the graph is a line passing through the origin with the slope 3 over 4. Notice the slope of the line and the constant of variation are the same. On the other hand, these data pairs don't have a constant ratio. So even though they are points on a line, they're not related as a direct variation. This lesson helped you understand direct variation. And this lesson was brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.